Dr. Deming made an appearance before us, not in person, but in an NBC film documentary entitled "If Japan Can, Why Can't We?" This film, shown at that meeting, highlighted Dr. Deming's impact on Japan's industrial quality. We are very pleased to have him with us today in person. Dr. Deming's formal education culminated in a PhD degree in mathematics and physics awarded from Yale, and his early career was devoted principally to studies of physical properties of matter while serving in several U.S. government organizations. During this time, he generated a strong interest in theories of errors of measurement and statistical sampling and made innovative contributions to these areas. He has been for 30 years a consultant in statistical studies with practice worldwide. A partial listing of his clients include railways, telephone companies, carriers of motor freight, automotive companies, and hospitals. He is perhaps best known for his work in Japan, which commenced in 1950 and sparked a revolution in quality and economic production. The Union of Japanese Scientists and Engineers instituted the annual Deming Prize to be awarded to a Japanese scholar for contributions in statistical theory or its application, and a medal to a Japanese company for use of statistical methods for advancement of precision and dependability of its products. In May 1960, he was decorated by the Emperor of Japan with the Second Order Medal of the Sacred Treasure. He has received the Schuart Medal from the American Society for Quality Control. He is the author of several books on statistical methods and over 150 papers. Since 1946, Dr. Deming has been a professor of statistics at the Graduate School of Business Administration of New York University and has lectured in numerous universities in this country and abroad. The title of his presentation is "The Teaching of Statistics in the Industrial Crises That Confronts the Western World." Dr. Deming.
It is a pleasure to be here amongst friends. In fact, so many friends. I must remind you that all statisticians are friends. My observation is that any statistician will help another and will look for ways to help him to improve his practice. My criticisms of statisticians and of the teaching of statistics this afternoon, you will believe me, I'm sure, are only my attempt to help statisticians to render better service to industry and science. The statistician's job in industry or in any other place is not just to give first aid treatment to problems brought to his attention, but to find problems that no one else can find and to lay out procedures for solution. For example, the 14 points for management to work on for the restoration of American industry, as I see it, came from observations in statistical practice. These 14 points are an outline as follows. Number one, innovate. Prepare for the long pull. allocate resources to fulfill the long-range needs of the company and of the customer. Short-term profits are not indication of good management. Anybody can pay dividends by deferring maintenance, cutting out research, or by acquiring another company. Paper profits are not indication of either intelligence, knowledge, or skill. Innovation requires resources, faith in the future, putting resources into plans for product and service for the future, putting resources into education, preparing for the long pull, putting resources into maintenance of equipment, furniture and fixtures, new aids to production in the office and in the plant where they would be effective, to learn about the deficiencies of the product or service being offered today. Intensify attention to the needs of the consumer. Learn how the consumer uses the product, how he misuses it, and how to improve tests of the product and service. It is a mistake to suppose that statistical quality technology applied to products and service offered at present can with certainty keep an organization solvent and ahead of competition. It is possible and in fact fairly easy for an organization to go broke making the wrong product or offering the wrong type of service. Even though everyone in the organization performs with devotion, employing statistical methods and every other aid that can boost efficiency. Number 2, learn the new philosophy. We are in a new economic age. We can no longer live with commonly accepted levels of mistakes, defects, materials not suited to the job. People on the job that do not know what the job is and are afraid to ask. Handling damage, failure of management to understand the problems of the product in use, antiquated methods of training on the job, inadequate and ineffective supervision. Acceptance of defective materials and poor workmanship as a way of life is one of the most effective roadblocks to better quality and productivity in America. The Japanese faced it in 1950. Unreliable and non-uniform were kind words for the usual quality of incoming materials in Japan in 1950. Good workmanship was impossible. Japanese management took aim at the problem and in time reduced it to a level never before achieved. American industry today faces the same problem. The road that Japanese manufacturers paved would be a good one for American management to copy. The only trouble is you cannot copy. They did not copy America. American industry cannot copy Japanese. Number 3, make it clear to vendors of critical parts that they must learn and use process control by statistical methods. There is no other way for them, nor for a company, to know the quality that is coming in, and no other way to achieve best economy and productivity. Purchasing management must learn the statistical control of quality. How many? Hundreds in many companies, thousands, tens of thousands in the country. Look at the job ahead. Who's going to teach them? They must proceed under the new philosophy. The right quality characteristics must be built in without dependence on inspection. Statistical control of the process provide the only way for the supplier to build quality in, and the only way to provide to the purchaser evidence of uniform, repeatable quality and cost of production. Number 4. For most companies, this will mean a drastic reduction in the number of vendors that they deal with. In particular, they must abandon the practice of having 2, 3, 5, 11 vendors for the same product. A multitude of suppliers enlarges severely the problems of ascertainment of evidence of quality. The theory that competition automatically regulates quality and price does not work in today's requirements for uniformity and reliability. Price has no meaning without a measure of the quality being purchased. Without adequate measure of quality, business drifts to the lowest bidder. The quality and high cost, low quality and high cost being the inevitable result. American industry and the U.S. government are being rooked by rules that award business to the lowest bidder. That competition does not regulate quality and price may sometime reach regulatory agencies. The purchasing managers of a company are not at fault for giving business to the lowest bidder, nor for seeking more bids in the hope of getting a still better price. This is their mandate from the top management. Only the top management can change their direction. The 14 points that I am describing, you see, must be undertaken by top management. Only they can bring these things about. They need help, and everybody in the company must help. But without top management, American industry cannot improve. Number 5. Use statistical methods to find out in any trouble spot what are the sources of trouble, which are local faults, which faults belong to the system, put responsibility where it belongs. You can do that only by statistical methods, not on judgment. No amount of knowledge of engineering, nor psychology, nor chemistry, nor physics, or production processes can give the right answer. Statistical methods must be used. Most of the problems belong to the system and are the responsibility of management. Dr. Duran put the percentage at about 85 for the system and the responsibility of management, and the other 15% to the workers on the job. A totally different picture from what is commonly supposed. Management must constantly improve the system. Number 6, management must institute statistical aids to training on the job. Training must be totally reconstructed. Books on training, practices on training will have to be changed drastically. Statistical methods, only statistical methods will tell you when a man is trained and when he is not yet trained. And when he is trained, you cannot train him further by the same methods. You hired him, you trained him. He turns out defective. What are you going to do? You have only one chance. Do it right. The only thing that you can do is find another job for him and try to train him better on the other job. Number 7, improve supervision. No one could possibly understand the magnitude of this job nor the importance of it without a long treatise, a long session on the subject. The problems are terrific. Foremen must have more time to help people on the job. Statistical methods are vital as aid to the foreman and to the production manager to indicate where fault lies. Is it local or is it in the system? Only a control chart or similar statistical method will tell you the answer. Judgment is not the answer. Judgment is hazardous. The usual procedure by which the foreman calls a worker's attention to a defect may be wrong, is certainly wrong in most organizations, and defeats the purpose of supervision. This is just one little item of many that must be changed. Number 8, drive out fear. Most workers, and even people in management, do not understand what the job is, nor what is right and what is wrong. Moreover, it is not clear to them how to find out Many of them are afraid to ask questions or to report trouble. Trouble with equipment, trouble with materials that they're trying to use. The economic loss from fear is appalling. It is necessary for better quality and productivity that people feel secure. SE, from the Latin, means without. Cure means concern, fear. Secure means without fear, not afraid to ask, not afraid to comment, not afraid to offer a suggestion, not afraid to do the job. A dialogue recorded for me by a friend read like this on the job. A millwright on the job. To the foreman, this bearing is getting warm. We ought to do something about it and do it now before it freezes and carries the shaft along with it, perhaps. And the foreman says, we can't stop now, not now. We have to get our quota out, our quota of castings. We have to get them out. The bearing freezes on the foreman's shift, takes the shaft along with it, and the whole production line is shut down for 4 days while they get a new shaft from Baltimore. Typical. Why? Because the foreman cannot work for the company. He has to work for the foreman. That's his mandate, to get this stuff out, no matter what. Fear. Terrific toll. 9, break down barriers between departments. People in research, design, and sales must learn methods of production and learn about problems encountered with various materials and specifications. Otherwise, there will be losses in production from necessity for rework and from attempts to use materials unsuited to the purpose. Why don't these people spend time in the factory? Follow me around. See the problems in advance, not after it's too late. Any statistician sees the problems any day. Number 10, eliminate numerical goals for the workforce. Slogans, posters, pictures, urging people to increase productivity. Sign their work as an autograph. 0 defects. These devices are management's lazy way out. They indicate desperation and incompetence, despair, hoping that somebody will pull them out. Number 11, look carefully at work standards. Do they take account of quality or only of numbers? Do they help anybody to do a better job? Work standards are costing the country as much loss as poor materials and mistakes. There's a better way with the help of statistical methods. Number 12, institute a massive training program for employees in simple but powerful statistical methods. Your purchasing departments, the whole force of management, supervisors, people that train, everybody on the job must learn statistical methods. Some must learn more than others. Thousands of people must learn. In one company that I work with, they're going to train 50,000 people. Not next week. It's going to take a long time. But they're going to do it. Number 13, institute a vigorous program for retraining people in new skills to keep up with changes in model, style, methods, materials, and at times, if advantageous, new machinery. There's too much talk, incidentally, about need for new machinery and automation. Most of it's nonsense. Most people have not to learn to use what they have. With more time, I could give many illustrations. Remember this. In Japan, where they are using present equipment to the best advantage and no further capacity can be squeezed out, There is only one way out to increase production, and that is by automatic machinery. There is no labor force to draw from. There are no unemployed to draw from. Everybody is at work. I'm not an economist, but I see quite different conditions here. I read about figures on unemployment. Those different economic conditions required different points of view. One cannot copy unless he knows what he's doing. Number 14, make maximum use of statistical knowledge and talent in your company. Provide statistical guidance, statistical teaching. Well, those are the 14 points. Anybody can see that this is a long pull. How many years? 10 years may show a difference, 15, 20, 30. And neither American management nor the teaching of statistics will be recognizable by that time. American industry can move along only with the help of statistical methods. But statisticians are not helping. My ultimate aim is improvement of statistical practice. Improvement will come from better teaching and better textbooks. Also from guidance to people that are doing statistical work in industry. It'll be a long pull, as I have said. A number of simple but essential statistical principles capture the imagination of young people. Operational definitions are an example. In my experience, high school students are fascinated with the logical exposition of the fact that an object cannot be exactly round, that arrival at exactly 3 o'clock cannot be defined, that there is no true value for the speed of light, nor for the number of defective items in a lot, nor for the number of inhabitants of Detroit. They are equally fascinated, these young people, in my experience, with the fact that the label on a blanket, reading 50% wool, can have any one of 100 meanings, none right and none wrong, for the simple reason that the choice of definition depends on the purpose of the test. It is a further interest to them that there is one possible set of meanings for purchase of a single blanket and a whole new set of meanings for purchase of a run of blankets, as for an army, for a hospital, a large retail store, or a wholesaler. Some high school students of today, if introduced expertly to the study of statistics, on some of the points that I've just mentioned, for example, would pursue statistical studies in later years and make contributions to research and industry. And you may say, well, that's a long way off. It is a long way off. American industry faces an equally long period of time to reach competitive levels. Challenges face statisticians today as never before. The whole world is talking about safety in mechanical and electrical devices, in automobiles, for example, safety in drugs, reliability, due care, pollution, poverty, nutrition, improvement of medical practice, improvement of agricultural practice, improvement of quality of product, breakdown of service, breakdown of equipment, tardy buses, trains, and mail, need for greater output in industry and in agriculture, enrichment of jobs. The consumer requires month by month ever greater and greater safety, and he expects better and better performance of manufactured articles and of service. The manufacturer has the same problems in his purchases of materials, assemblies, machines, and use of manpower. He must, in addition, know more and more about his own product. These problems cannot be understood. They cannot even be stated nor can the effect of any alleged solution be evaluated without the aid of statistical theory and methods. One cannot even define operationally adjectives like reliability, safe, polluted, unemployed, on-time arrivals, equal in size, round, random, tired, red, green, or any other adjective for use in business or in government except in statistical terms. Likewise, a standard as of safety, or a performance or capability, or a government regulation. What is due care? What is care in manufacture? Care can be defined in operational terms with the aid of statistical methods. Due care cannot be defined. It has no communicable meaning. It requires no imagination to perceive that this distinction between care and due care is important for lawyers as well as for engineers.